Alright, yeah, so let's try graphing some tangent and cotangent equations, making the graphs given an equation. So the equation that I have is y equals 3 tangent 1 half x minus 2 pi minus 2. So when it comes to graphing tangent and cotangent, kind of like my procedure for cosecant and secant, I start with the asymptotes when it actually comes to the graphing. The asymptotes and the period kind of give me like the bulk of how this thing will look, and then you just have to do a little bit of thinking about where to put some relevant pieces. So before we do that, I guess let's just write out some useful information that you might be asked at some point. So the period of this, the period of tangent and cotangent, the mother functions, the period of those is pi, which means that the period of just a generic tangent or cotangent function is pi over b. So compared to the other four functions where the period is 2 pi over b, tangent and cotangent is just pi over b. So pi over b, which is 1/2. So pi over 1/2, which is actually just 2 pi. So the period is 2 pi. The phase shift, we can say something about that, even though personally when I'm graphing these I don't actually use the phase shift for graphing it, but we can still calculate the phase shift, which is the exact same thing. If you have your equation written this way where b has not been factored out of the argument, then the phase shift is c over b. So 2 pi over 1/2, which is 4 pi, and since there's a minus sign here, that's to the right, 4 pi units to the right. We can also say what the midline is, which is nice and easy. The midline is -2. It's just given by d, whatever this constant is that is added onto here. That's the midline. Okay, right. Okay, so now let's actually get to graphing this thing. And like I mentioned, when I'm graphing this, my sort of starting point is finding the asymptotes, which really just amounts to finding one asymptote and then using the period to calculate where some other asymptotes are. That's the way that I do it, at least. So tangent has an asymptote. Tangent is sine over cosine, so tangent has an asymptote whenever cosine is 0. One place where cosine is equal to 0 is when theta is pi over 2. And you can think of this whole piece inside here as being theta. So you want to solve for where that piece equals pi over 2, because there will be a tangent there. An asymptote there. So we solve 1/2 x minus 2 pi equals pi over 2. Add 2 pi to each side to get 5 pi over 2. So then there's an asymptote at x equals 5 pi. So, and I could use that for my graph, like, make my graph and then mark off where 5 pi is, but it would be kind of far into the positive x. It's sort of far away from the origin. Me personally, I like to kind of center my graph as close to the origin as possible, just because I think it's prettier. There's no problem with not doing that. You could mark off, your graph and then find 5 pi over here and then make your 1 or 2 periods of the graph sort of further along the x-axis. That's fine. But me, like I said, I like to center it as much as possible around the origin. So what we can use, though, is that if there's an asymptote at x equals 5 pi, and we know that the period is 2 pi, that means that every 2 pi units away from 5 pi, there's an asymptote. So I'm just going to subtract off 2 pi from this to find where some other asymptotes are. So there must be an asymptote at 3 pi, there must be an asymptote at pi, and there must be an asymptote at negative pi. So these will center right around the origin. So that's kind of where I'll start my graph. Let's see, the other thing that I kind of want to think about is this midline. Since the midline is -2, that's a downward shift of 2 units. So some of the, what I consider to be critical points of this tangent curve are going to be below the x-axis. So maybe I'll skew my graph slightly towards the negative y. Skew it a little bit towards the negative x-axis. Not negative x-axis, sorry, below the negative x-axis, so the negative y-axis. Like that. Okay, so here's my graph. I know I've got asymptotes at plus or minus pi, so I will mark those off. Say this is pi, over here, negative pi. You don't have to put the asymptotes on there if you don't want, but I think it's really helpful. Okie dokie. So, looking at the generic graph of tangent, that's not the generic graph, that's actually the graph that we're making. This is my second time making this video. I did these examples and I literally got to like the last 20 seconds and my computer crashed. So right, here's the generic graph of tangent. And the key piece that I'm going to note is that the graph of tangent crosses the midline at exactly the midpoint between asymptotes. So you look at any set of asymptotes, you look at exactly the midpoint between them. That's where the graph of tangent crosses the midline. The midline of the normal tangent is y equals 0. But in our graph, the midline is y equals -2, which means that between these two asymptotes, the graph crosses at y equals -2. So here's -2. And it's probably really obvious, but the midpoint between negative pi and positive pi is 0, which means that this graph is going to pass through this point right here. So maybe I'm just move this really quickly because otherwise it's going to be in the way. -2. There we go. Okay. So there is that. The very last thing to look at is our A, because A does sort of two things. One, if the absolute value of A is greater than 1, then it kind of like tightens this whole thing. Like the way that I kind of think about it is if this strand right here was a string and I grabbed both ends of the string and like pulled it tight, it would kind of make this right here where it crosses through the midline, it makes it a little bit steeper. It kind of tightens it. So that's what happens with A if the absolute value of A is greater than 1. If the absolute value of A is between 0 and 1, then it would kind of do the opposite. It would sort of scrunch everything together. So that's one thing to keep in mind. The other thing to keep in mind is whether or not A is positive or negative. So if A is positive, then yeah, your graph is going to look like this. It's going to take that same sort of shape where it's always increasing. If A is negative, that flips everything over the x-axis, and so it would be kind of going downhill. So our A is positive. Our A is +3, so it's still going to have that upward incline. And as it crosses through the midline right here, it's going to cross through somewhat steeply because of that 3. So I might maybe draw it something like this. There. And that's one period. So if we wanted to draw another period, I would do a similar idea. So the next asymptote after pi is 3 pi. So here's pi, here's 2 pi, here's 3 pi. So there's an asymptote there. And same thing. Graph of tangent is going to cross the midline here at -2, and it's just going to mimic exactly what we already did. Just like that. So those are, that's 2 periods of this particular graph. Let's try another example that is a cotangent example. So y equals -1/2 cotangent of 2x minus 3 pi plus 3. So some relevant pieces, something that I will use is the period. The period of this thing is pi over 2. The phase shift must be, if I divide 2 out of this thing, this becomes 3 pi over 2. And that would be, again, to the right. Just sort of like listing that out, because sometimes you might be asked that in homework or on a quiz. I don't use it. Again, I don't use the phase shift at all. You just saw the only thing that I use is the essentially just the asymptotes, and then kind of like this symmetry between the asymptotes. That's how I graph these. And then this has a midline at 3, y equals 3, so everything has been shifted up. And I'm just taking note right now that a is -1/2. So it's going to have that sort of compressing, and everything is going to be flipped over the x-axis, which gives kind of an interesting look to cotangent. Yeah, okay. So now, asymptotes. And you've got to take a second and think, because previously we decided, well, tangent has an asymptote at pi over 2, but now we're looking at cotangent. Where does cotangent have asymptotes? Well, cotangent is cosine over sine. So it's going to have asymptotes whenever sine equals 0. Whereas the first place that sine equals 0, it's at x equals, or theta, I should say, theta equals 0. So we'll solve, where does 2x minus 3 pi equal 0? And that's at x equals 3 pi over 2. Okie dokie. So yeah, this time everything is shifted up 3 units, so kind of the important part of the graph is all occurring above the x-axis. So maybe I'll do something like this. Kind of like we're zooming in above the x-axis a little bit. Right, in a similar situation to what we encountered previously, that the asymptote I calculated is at 3 pi over 2, which, you know, is not super far out, but given that the period is pi over 2, this also means that there are asymptotes at pi over 2, at 0, and at negative pi over 2. So, yeah, maybe kind of this is the interval that I'll be looking at. It's centered right around the origin. So, let's see here, give myself enough room. I'll say this is negative pi over 2, and then 0, and then over here, positive pi over 2. So, and just for my own clarity, I'll put a dotted line through here. It's going to be kind of hard to see, but just so I don't get mixed up looking at my own picture and think that the asymptotes are just plus or minus pi over 2. So here are my 2 different periods where I can draw cotangent. Same deal with tangent. Cotangent crosses the midline at the midpoint between asymptotes. So here's the graph, just the mother function of cotangent, and right in between the asymptotes is where the graph crosses the midline. So it's the same thing here. The midline is, again, it's 3. So the graphs will cross that midline right at the midpoint between the asymptotes. So plus or minus pi over 4. All right, then there's going to be this 1/2 factor, which scrunches everything down. But the big thing to note is this negative piece. Because what happens with cotangent when you flip it over the x-axis, which is what happens, the negative cotangent just flips everything over the x-axis. So rather than kind of coming down like this, it sort of starts coming up in this sort of way. This sort of way. But notice that that looks exactly like tangent. So negative cotangent, tangent looks a lot like negative cotangent, cotangent looks a lot like negative tangent. So this thing will come up. It's going to come up through the midline rather than coming down through the midline. And because there's the 1/2, that's kind of like a compression factor. So previously we said this 3 makes everything come up through the midline faster. The 1/2 is going to make it come up through the midline a little bit slower, so not quite so steep, something like this. Whoops, got a little too close to the asymptote there. Yep, that's how it's looking. So just like that. Okay, so that is how you graph tangent and cotangent given an equation. Let me know what questions you have.